Hello everyone, welcome to another session of Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. So as an outline of this lesson, we are going to learn what are network branches, what are network rungs, and what are the rules when developing a PLC logic. We are going to begin with the branches in a ladder logic program. We can use branches in the main rung to program parallel circuits with ladder logic programming language. We can insert several contacts into the branch and thus achieve parallel circuits of series connection. For example, we have this sample rung. This is a ladder network and it has one rung. And on this network or rung, we have 4 branches. And when any of these branches allow the flow of logic from the left power rail from its left side to its right side, then this lamp becomes true. So this is what I'm saying in essence. What I'm saying is that when S0 becomes true, then power is going to flow from its left side to its right side. Then we are going to have a logic 1 at this point, and as such the lamp becomes true also. And when S1 is false, then it's going to allow the flow of logic, and there will also be logic 1 on this point. And similarly for S2 when it is true, and for S3 when it is true. So this condition makes them to operate in parallel, and it makes them to become branches, because logic can either flow through S0 to the lamp, or through S1 to the lamp, or through S2 to the lamp, or through S3 to the lamp. Alright, the lamp carries a signal 1 if one of the following conditions are fulfilled. That is, S0 is true, S1 is false, S2 is true, and S3 is true, which is what we just explained. The following rules apply to simultaneous branches. Simultaneous branches have the same start and stop points, like we just explained. They all start from the same point and they should terminate at the same point for them to be simultaneous branches. To delete a simultaneous branch, you must delete all the elements found in that branch. Okay, so to delete a simultaneous branch, for example this branch S3, then all the elements that are found on this branch must as well be deleted. All right, so we are just going to jump into our software to see how we can create a parallel branch. So to create a parallel branch, I'm going to create a new project. We have already learned how to create a new project in our previous tutorial. If you want to understand on how to create and simulate your first project, then you can head on to our previous tutorial. We already explained that. So I'm going to be using this processor 2020. I'll allow the project to load my processor for a minute. Next, I'm going to configure the processor. I will drag some discrete module GDI 1602 and this output module GRA 1605. Okay, now configure the module by double clicking. Go to the module IO objects. So it's an input module. I'll generate all the input addresses, and I will create my variables S0, S1, S2, S3. So these are my variables which I've created. I will do the same for my output module. I'll generate all the output addresses and I will create the output variable lamp. Okay, so I've generated all my output variables. I can now close this. Output and input variables. So if I go to my variable sheet, I'm going to see all the variables which I've created. I will just close everything. Next, I'm going to now create a new project. So I'll go to section and click new section, then I'll call it the branch example. You select the language ladder, then I'll take OK. So this is my programming environment, and I'll create my parallel circuit here. Now I've created my ladder network. So I'll give them addresses. This is S0, S1, S2, S3, and finally the lamp. Okay, so this is what we are saying. We are saying that the moment any of these instructions allow the flow of logic 1 to this point, then this lamp logic becomes automatically true. Okay, so back to our presentation. That's how we can create a parallel branch. And next, we are saying that to delete a simultaneous branch, you must delete all the elements found on that branch. What does that mean? We mean that, if I go back to my software, we mean that suppose that we have other instructions on this branch. That is, this branch does not only depend on S3. Let's say this branch also depends on S0. For example, having something like this. So I'll place a contact here, and then I'll give it S0. Okay. Suppose we have something like this. So in this branch can only be true when S3 and S0 are both true at the same time. Okay. So I cannot delete S0 without deleting S3. So deleting S0 means I have to delete all the elements on that branch. That's what it means. Okay, so now let's talk about rungs. What is a rung? A program is always mapped to one or more networks. A network contains a power rail on the left where one or more rungs originate. The binary signal scans are arranged in the form of contacts on the rungs. The serial arrangement of the elements on the rung creates a series connection. Arrangement on simultaneous branches creates a parallel connection. A rung is closed by a coil or a box in which the result of the logic operation can be written. Okay, so like this example, in this example, we have two rungs. This is rung 1. Okay, this is rung 1, and this is rung 2. And this entire diagram, we call it our ladder network. So it has two rungs, rung 1 and rung 2. So this is our rung. This is our rung 1, and this is our rung 2. Okay. Now, what are the rules? What are the rules of running and executing rungs? Okay, rungs and network are executed from top to bottom and from left to right. So this means that the first instruction of the first rung of the network is processed first. So we mean that this instruction and this instruction are processed first. Okay, so this is processed first to give this output. Then next, this is processed to give this output. And after we have processed this rung, then we move to the next rung where this is processed to give this output. Next, this is processed. Then next, this is processed. Then next, these two are processed. Okay, so all instructions of this rung are then processed. Okay, after this, Then comes all the other rungs of the first network. The next network is processed only after the rungs have been run. Okay. All right. I hope that makes sense. That will bring us to the end of this presentation. So to review what we have learned, congratulations, you have learned what a network is, what a rung is, and the rules for developing a PLC ladder logic. Okay. And please, if you like this video or you find this video helpful, give it a thumb up, share it, and subscribe. And in the next video, we are going to learn what bit logic instructions are. So thank you very much for watching, and see you in the next video.